All right, guys, you need your note sheet. Note sheet from, or need a new note sheet. So, what we did yesterday was long division. We divided two polynomial expressions using long division. Now, what we're doing today is synthetic division.
So it's like the fake division.
Kind of, and it's a little bit nicer and a little bit simpler in some ways. So, when we do synthetic division, there's a few main steps to it. The first is getting the problem set up. Now, the way we set the problem up is first, we're going to draw what I call kind of the little cubby and a line. This is the main setup for the problem. So we draw our cubby and our line. All right? Okay. Now, what goes inside the cubby comes from this part here, our m minus 3. So what we're dividing the problem by, we're going to set it equal to 0 and solve for the variable. So here, really variable at the biggest power, just the variable itself. So we have m minus 3. So we add 3. So m is equal to 3. So we can go straight to this step, especially if m, the variable at the biggest power that we're dividing it by, is 1, because it has to be 1. We'll see what happens if it's not later. And we take that number and put it into the cubby. Questions on this so far? Next step involves our other expression. And we take the numbers in front of each variable, and we're going to put it across the top here. And if there are any missing, we're going to fill it in as 0. So our first term of this expression is m cubed, and the number in front of m cubed is, okay. So the number in front of m cubed is 1. So the next one would be m squared, which is negative 13. Then we have m to the first, our m, which is 24, and our number without a variable is 18. So we need all the coefficients, and if one of them is missing, we fill it in as 0. But here we have them. We have our m cubed, m squared, m, constant term. And the number of numbers that we have going across that line is always going to be one more than the degree. So the degree is 3. We should have 4 numbers. We good with this so far? Okay. Last part of the setup is we bring the first number down. First number always comes down. Okay. We ready for the first step? Okay. Now with this here, what I'm about to do is I'm about to draw a whole bunch of arrows. I would not draw them because it's going to get very messy very quick. I'm going to be drawing the arrows so that we see what's going where, okay? First main step in this here is we're going to take the number inside the cubby and multiply it by the number below the line. So what we're going to do is 3 times 1, which is 3. And we're going to take that number and put it below the second number here. So the number in the cubby times the number below the line. So 3 times 1 gives us 3. We put it under the second number. Let's see something else. Questions on this so far? our next part of this is we're going to add straight down. So negative 13 plus 3 is questions on this here. Okay. Not what I wanted. Then we're going to multiply again. So we're going to say, yes, 3 times negative 10 this time, which is indeed negative 30. And we take that number and put it above the line under the next number on the list. So it's underneath the 24. And then we're going to add straight down again. Yes, we're going to add all the way across. And it is.
Is it on every time you add?
For a synthetic division, we add straight down. So it's 24 plus negative 30, which is really 24 minus 30. Because plus and negative minus. Yeah. Negative 6. Questions on this here? We feel good with this so far. Well, we're going to do this again because we now have to multiply the 3 times negative 6, which is negative 18.
Hey, that's just 0.
And it is indeed 0. Since we don't have any numbers after the 18, we're done. Okay? Questions on anything we've done so far? Because yes, there are a lot of arrows, a lot of things going back and forth, but it's really bring the first number down, multiply it by the number in the cubby. So 3 times 1 is 3, put it under the next one. Add, take that number, times it by 3. Add times by 3, add times by 3. So we feel at least somewhat comfortable getting to this point here. Now we need to interpret what we've got. And what I always do is I put a box around the last number on the list. Because that number there is the remainder. The last number in that list is the remainder. So since it's 0, we do not have a remainder. Now our variable this time was m, yes? So if you end up switching to x, I'm not going to care too much. We just need a variable there. So this is our remainder. Our number next to it is going to be the number without a variable. It's our constant term. The one next to it is going to be m to the first. And the next one is m squared. If there was a number in front of that, it would be m to the third, m to the fourth. We're just increasing by 1. And what this tells us is that our final answer is m squared minus 10m minus 6. And that's it. We like this a little better than long division. Because again, it is a little more tedious, especially the first time we do it.
I feel like this one will probably be less tedious.
Yes. Definitely not as tedious as the previous one. We ready to move on to the next one? Okay. We have this one here. We're going to do this by synthetic division, so we'll set up our problem. We'll have our cubby hole in line. Now to find the number that goes in the cubby hole, we're going to take what we're dividing this by, which is you put v plus 4. Now, as long as that v, that variable with the biggest exponent, is 1, we don't have to do anything else. It gets a little tricky. Not so much tricky, it just adds a step if it was 2v instead of just v. And all we need to do is solve this here. So we can subtract 4, telling us v is negative 4. It goes into the cubby. Numbers across the top. Start with v to the biggest exponent, so v to the 5th, which is going to give us 8. Almost. Yes, because v to the 5th would give us 8. V to the 4th would give us 32. There is no v to the 3rd power v cubed, so we have to put it in as 0. V squared, still missing, so it is also 0. V to the 1st power of v would be 5. And our constant term, our term without a variable, is 20. So if we're missing one, we have to put one back in. So we have v to the 5th, which is our 8. V to the 4th is our 32. V cubed, v squared are missing, so we have to put them in as 0. And then we bring the first number down. So any questions on how we got this set up? So this time I'm not going to be using the highlighter and drawing all the arrows, but I'll still be writing in the different colors. Because the first thing we're going to have to do is negative 4 times 8. And it would be negative 32. And we take that number and put it above the line under the next one. And at this point here, we add straight down. So 32 plus negative 32 is 0. This next multiplication is nice because we're going to take the negative 4 in the cubby, multiply it by the next number below the line, which is
Oh my God, it's
Zero.
zero.
Negative 0. And then we would add 0 plus 0 is 0. Now, I'm going to save time because negative 4 times 0 is still 0. Add straight down, 0 plus 0 is, lo and behold, still 0. Negative 4 times 0 is still, well, 0. This time we have 5 plus 0, which is 5. Okay. Now we actually have to do another multiplication because we're saying negative 4 times 5 is negative 20. Line. Add those two together and we get 0. And I always put a box around the last one because that is our remainder. With long division and synthetic division, the number of terms that we have for the remainder is always going to be one less than the number of terms we're dividing by. So the number of terms we're dividing this by is 2, so the remainder would have 1. If what we're dividing it had 3 terms, the remainder should have 1 or 2. Can't have more than that. Questions on this here? We're ready to put the variables back. So 0 is our remainder. 5 is just going to be 5. Next to it, we have v to the 1st, v squared, v cubed, and v to the 4th. Yes. If the number doesn't have a sign in front of it, it just means it's positive. Bless you. Now we don't have to list the 0v cubed, 0v squared, or 0v because they're just 0. So it's really just 8v to the 4th plus 5. And that's it. Questions on this here? Good? Okay. Need to step out, let me know. You ready for the next one? Okay. This one's a little bit different. So what we're dividing it by, because setup's still going to be the same. We're going to still have our cubby and our line. But this time we don't have just x, we have what? 3x. Well, we need to get rid of that 3, so we're going to divide both of these terms by 3, which will just tell us that this is now just being divided by x minus 1/3. Because again, we need that x to be 1. And yes, we can't just do that to one side, we have to do it to everything. So our 3x cubed divided by 3 is just going to be x cubed. 4 does not divide evenly. We have 4/3 x squared. And that division of 3, we can just do that in the calculator. Questions on this so far? So if there's a number in front of that x or that variable, we have to divide the whole thing by it before we can start the problem. But from there, everything else goes exactly the same way. We take what we're dividing it by. So now it's our x minus 1/3. And solve for x. So here we would add 1/3 to both sides, telling us x is 1/3, and 1/3 goes into cubby. Numbers across the top. We'd have 1 for x cubed, negative 4/3 for x squared, negative 17/3 for x, and 2 for our constant term. And just like before, we bring down the 1. Are you ready for this here? So the first thing we're going to do is our 1/3 times 1, which is, well, 1/3. That's the nice thing with multiplying by 1. Next thing we need to do is add straight down. Well, if you're not great with adding fractions, that's fine. Because we can say, I think it's 4/3 plus negative 1/3 plus 1/3. Had it flipped. Negative 4/3 plus 1/3 is negative 1. And then we're going to do 1. Yes. 1/3 times negative 1 would be negative 1/3. And again, we're going to add straight down. Negative 17/3 plus negative 1/3 is negative 6. And then we're going to multiply again, 1/3 times negative 6. And in the calculator, we could have been doing this each times. No, just 1/3 is negative 2. Then what would we have to do to the 2? We would need 2. Because we have 2 plus negative 2 is 0. So even though we had fractions this time and fractions in fractions, the calculator, the 30XS, will do all that for us. We don't have to really worry about that there. And again, just like the last few, the remainder has been 0. If we plug the variables back in, the number x to it, -6, so just going to be -6. We'll have x and then x squared. Telling us that we have x squared minus x minus 6. The only time we'd have to do something with that division of 3 or have to apply it back to it is if we have a remainder left over. But that's it. Questions on this here? How do we feel about synthetic division? We feel good with this here? Okay. Do we need to see another example of synthetic division? No. Because the only time it gets kind of tricky or challenging is when the number in front of x is not 1. We get this here.
It's really just divide everything and then do the process.
Yes. Yeah. We can go on and look at this one here. Because here, we actually have to divide everything by 7. And luckily for us here, this is actually kind of nice. Because our 7x divided by 7 is x. 7 divided by 7 is 1. So those divided nicely. The other side, 42 divided by 7 is 6. Unfortunately, 33 does not divide by 7 nicely. Yes, to find the number that goes in the box, we'd set our x plus 1 equal to 0 and solve, telling us it's -1. Numbers across the top, we'd start with 6 for our x squared, 0 for our x, and -33/7. Bring the 6 down. We'd multiply. -1 times 6 is -6. 0 plus -6. -6. -1 times -6. 6. -33/7 plus 6. I think it's 9/7. -33/7 plus 6. So that's our remainder. Now, let's go put the variables back in. Our -6 next to the remainder would be the term without a variable. And the 6 would have x. So we have 6x minus 6 plus 9/7 over, because our x plus 1 with what we're dividing it by. Yeah. Fraction and a fraction. Yes? Well, what did we do at the start? We divided everything by 7. So to adjust this, well, I'm going to have to multiply the top and bottom of it by 7. Now the bottom, yes. Yeah, because since it was 0, we didn't have to worry about it. There is no remainder. And part of the reason that we have to do this or try to fix this is that we have a fraction in a fraction. Fraction in a fraction.
Why do we have 7?
So it's really fixing this fraction here to make it not be a fraction in a fraction. Because 9/7 times 7. 7 times 7 is 9. Okay. Now we multiply through by 7. 7 times x is 7 times 1. That's what we were dividing by originally, 7x plus 7. So it kind of fixes that and it goes back to what it was to begin with. So really we can just take the remainder, multiply it by the number we divided out, and put it on top of what we were dividing originally. Because that's the only key.
How we had it first, would it be?
I'll take it that way, yeah. Questions on this here? Now we will come back to this one. I want to go to the remainder theorem first. Now, there's not a spot necessarily for the remainder theorem because there's not a whole lot to it, okay? There's not a spot for it. There's not a spot for the remainder theorem, but we will come back because I added this back in, and okay, so you don't necessarily have to write it down. It's not in the notes. But here's what the remainder, so here it is. If a polynomial f of x is divided by x minus k, then the remainder r is equal to f of k. Okay? What this is saying is if we divided something, we divided a polynomial by x minus k, the remainder, what's left over, the remainder for it, will be the exact same as if we took that value of k and plugged it in. So let's see how this works. So if we looked at this here, 5x cubed minus x squared plus 13x plus 29 when x is equal to negative 4. Well, with synthetic division, we set the problem up, yes? And then we got x by itself. We took what we're dividing by, set it equal to 0, and solve for x, yes? Here they already did that. They're saying x is negative 4. So what we can do is take that negative 4 and put it into our value. We don't have to do that. They're essentially telling us to divide this by x plus 4. We plug the negative 4 in. Numbers across the top. 5, negative 1, 13, 29. We bring down the 5. Questions on this so far? Negative 4 times 5. Negative 20. We put it under our next one and add straight down. Negative 1 plus negative 20. Negative 21. Negative 4 times negative 21. Negative and negative is going to make it positive. And 4 times 21 is 84. Now, we could be doing all these calculations in the calculator. You don't have to do these by hand. Because I can type in negative 4 times 5, negative 20, plus negative 1, negative 21. 4 times negative 21 is 84. 84 plus 13 is 97. Negative 4 times 97. 8, carry the 2. Negative 388. We add straight down. 9, 3, negative 388. Plus 29, negative 350. Okay. So that's our remainder. Questions on this here? Now, what it wanted us to do is evaluate this when x is negative 4. So what that also means, in the way we've done this, especially in the first section, I'm just grabbing a note sheet, is that we plugged negative 4 in for x in every place where there's an x. So we would have 5 times negative 4 to the third power minus negative 4 squared. 13 times negative 4 plus 29 is negative 359. Both ways gave us the same answer, yes? Yeah, so the remainder, and what the remainder theorem states is if we did the division, so here negative 4, the remainder, and what we would get with evaluating, plugging it in, will be the same. So we didn't have the remainder theorem specifically stated in this, but that's all it's saying. I just added back in, but I didn't have it in the notes. Also, it really doesn't add a lot. It's just, if we divide what the remainder is and what we would get for plugging it in are the same. Questions on this here? But that does tell us something kind of important, because if we plug a value in, we evaluate it, and it gets us a value of 0, it means it's a solution, which means it will divide evenly. So here, if we're going to do this, we'd plug 5 into the cubby and put the numbers across the top. So 4 for x squared, negative 10, negative 21. And bring down the 4. 5 times 4. 20. Add straight down. Negative 10 plus 20. 5 times 10 is 50. And lastly, negative 21 plus 50 is 'So the answer for this is 29. Questions on this here? We can do one last one. Number inside the cubby is going to be 2. Numbers across the top is going to be 5 for our x to the 4th, 2 for our x cubed, 0 for our x squared, negative 20 for x, and negative 6. We bring down the 5. And again, once we get it set up, all the rest of the calculations we can do in the calculator, because 2 times 5 is 10. 2 plus 10, 12. 2 times 12, 24. 0 plus 24, 24. 2 times 24, 48. Negative 20 plus 48, 28. 2 times 28, 56. Negative 6 plus 56 is? So the answer is 50. Okay. Questions on this here? Questions on any of this so far? What do we think about synthetic division? We like it a little bit nicer than long division? Okay. Now, before we do the last problem, I'm going to go on and give you this here. So the homework on page 187, 12 through 18, 25 through 28. 12 through 18 is our synthetic division, just you're dividing it, getting a solution. 25 through 28 is using synthetic division to evaluate. Now, before we call it done, we're doing one last problem. I want to go back to this one here. Now, for the longest time, especially when I was in high school, really when we did synthetic division, what we were dividing it by was always a 2-term. We did not have a quadratic or anything higher. A higher power than 1. It would just be x minus 4. We did not have a square term. And for the longest time, I thought that it just wasn't possible. It is possible to do it. There's just a few more steps to it. Okay? Now to do this here, we do have our setup. We do have the cubby, but the cubby line is going to be a little bit bigger. And we don't have one line, we have two. Now, for what we're dividing by, we still set this here, x squared minus x minus 4 equal to 0. We still set it equal to 0, okay? But this time, we're not getting x by itself. We want to get the x squared term by itself. So to do that, the first thing we can do is add 4. Telling us x squared minus x is equal to 4. Add x, telling us x squared is equal to x plus 4. So this time, instead of just getting one term by itself, we got to get two. We got to get the x and the number. So since we have x term as our biggest term, and what we're dividing by, we get it by itself. Because all the others, x. First power was the biggest one, so we got it by itself. Now these will still go in the cubby, because we still will have the 4 from the constant term, but we also need the number in front of x, which is 1. So we actually have two numbers in there. We have 1 and 4. Not 14, just 1 and 4, two numbers. Okay? Numbers going across the top are still the same. We have 2 for x to the 5th, 1 for x to the 4th, negative 15 for x cubed, negative 2 for x squared, 10 for x, and negative 24. Yes, we have two lines because we have two numbers now. First number will come all the way down. So the 2 comes all the way down below the second line. But we have two lines, yes? Which means the second number comes down to the first. Questions on this here? It is a lot to it. It is more to it. Now we're still going to multiply everything by the first number under the line. So our first number that we have is 1. So 1 times 2. 2. So we have 2 here. And we'll add those together and get 3. Now we also have our other number, yes?
So would you do the 2?
We'd still do the 2. So we'd have 4 times 2, which is 8.
Wait.
Yeah.
Do the 2 that you got.
Yeah,
The
first
first 2.
2. Yep, first 2. So 2 times 1 gave us 2, 4 times 2 gave us 8. Now we'll still add straight down. Negative 15 plus 8 is negative 7. Now we're going to do this again. We're going to have our 1 times 3. And 1 times 3 is 3. And then we have our 4 times 3, which is 12. And again, we're going to add straight down. So on the bottom, negative 7 plus 3 is negative 4. Negative 2 plus 12 is 10. We multiply again. So now we're going to be multiplying our 1 by our negative 4, which is, well, negative 4. And then we'll have our 4 times negative 4. We're always multiplying by that very bottom number. Negative 16. 10 plus negative 4 is 6. 10 plus negative 16 is negative 6. Do it again. Now we're multiplying with our 6. We have 1 times 6, which is 6. And 4 times 6 is 24. And we'll add straight down. 6 plus negative 6 is 0. Negative 24 plus 24 is 0. Now, if you notice for the upper line, I can't go any further. Yes? we're done. Now, student mentioned this or brought this up. What we can do since we're finished as well is bring that other number down to the bottom. Yes? How many terms were we dividing this by? 3, yes? So our remainder should have 2. So these last 2 are our remainders. With the remainder, the first number is going to be our term without a variable. Second one be the term with x. But since they're both 0, the remainder is 0. Coming across the bottom, 6 is our number without x. Negative 4 is our term with x. 3 is with x squared, 2 is with x cubed, telling us our answer is this here. So yes, it is possible to do it with synthetic division. It does add a bit as we go bigger and bigger. But homework, no. But that's it. Because again, I wanted to show synthetic division with that so that y'all know it is possible, it does work. But with a lot of them, we just stick with our binomial. Now tomorrow, 4.51 is the lesson we're going to start tomorrow. You will not finish it in class, but you will start it. So you will, the sub will have the note sheets. I do have them here. You're going to start the note sheet, and then there will be a video here. I'll have it in YouTube too, so if you're not here, you can watch it there. But you'll come in, so you'll watch the video and take the notes. And I told the sub if at some point it gets going too fast, you can pause it, get caught up, and keep going. Okay? Part 1 will be tomorrow. Part 2 will be Thursday. And then you will get the assignment Friday. Okay?